about the subject artificial intelligence and machine learning, and in that we'll discuss about artificial intelligence. The first topic is future of artificial intelligence. Artificial intelligence is a revolutionary field of computer science which is ready to become the main component of various emerging technologies like big data, robotics, and IoT. It will continue to act as a technological innovator in the coming years. At present, we can define AI as it is the ability of machines or computer controlled robot to perform tasks that are associated with intelligence. So, AI is computer science which aims to develop intelligent machines that can mimic human behavior. Then, applications of AI. The first one is gaming, and the second one is vision system, and the final one is speech recognition. Apart from this, we have many n number of applications of AI. Gaming. AI plays crucial role in strategic games such as chess, poker, tic-tac-toe, etc., where machine can think of large number of possible positions based on heuristic knowledge. The second one is vision system. These systems understand, interpret, and comprehend visual input on the computer. For example, a spying aeroplane takes photographs which are used to figure out spatial information or map of the areas. Doctors use clinical expert system to diagnose the patient. Then police use computer software that can recognize the face of criminal with a stored portrait made by forensic artists. And the final one is speech recognition. Can handle different accents, slang words, noise in the background, change in human noise due to cold, etc. The other applications are healthcare, security and defense, education, banking and finance, autonomous vehicle, manufacturing, entertainment, and workplace. The programming languages used in artificial intelligence are R programming, Java, Julia, C++, Python, etc. And the next and one of the main topics in AI is agents. An AI system can be defined as the study of rational agent and its environment. These agents sense the environment through sensors and act on their environment through actuators. An AI agent can have mental properties such as knowledge, belief, intention, etc. What is an agent? An agent can be anything that perceives its environment through sensors and act upon that environment through actuators. An agent runs in the cycle of perceiving, thinking, and acting. An agent can be human agent, robotic agent, and software agent. A human agent has eyes, ears, and other organs which work for sensors, hand, legs, vocal tract for actuators. Then robotic agent. A robotic agent can have cameras, infrared range finder, NLP for sensor, and various motors for actuators. Then software agent. Software agent can have keystrokes, file contents as sensory input and act on those inputs and display output on the screen. Hence, the world around us is full of agents such as thermostat, cell phone, camera, and even we are also an agent. Then we'll see about sensors, actuators, and effectors. Sensor is a device which detects the change in the environment and sends the information to other electronic devices. An agent observes its environment through sensors. Then actuators. It is a component of machine that converts energy into motion. The actuators are only responsible for moving and controlling a system. An actuator can be an electric motor, gears, rails, etc. Effectors. Effectors are the devices which affect the environment. Effectors can be legs, wheels, arms, fingers, wings, fins, and display screen, etc. Then intelligent agent. An intelligent agent is an autonomous entity which act upon an environment using sensors and actuators for achieving goals. An intelligent agent may learn from the environment to achieve their goals. A thermostat is an example of an intelligent agent. Following are the main four rules for an AI agent. First one is an AI agent must have the ability to perceive the environment. Rule 2 is the observation must be used to make decisions. Then rule 3 is decision should result in an action. And the final rule 4 is the action taken by an AI agent must be a rational action. The next topic is rational agent. A rational agent is an agent which has clear preferences, models uncertainty, and acts in a way to maximize its performance measure with all possible actions. A rational agent is said to perform the right things. AI is about creating rational agents to use for game theory and decision theory for various real world scenarios. For an AI agent, the rational action is more important because in AI reinforcement learning algorithm, for each best possible action, agent gets the positive reward, and for each wrong action, an agent gets a negative reward. Next, we'll see about rationality. The rationality of an agent is measured by its performance measure. Rationality can be judged on the basis of following points. Structure of an AI agent. The task of AI is to design an agent program which implements the agent function. The structure of an intelligent agent is a combination of architecture and agent program. It can be viewed as agent is equal to architecture plus agent program. Following are the main three terms involved in the structure of AI agent. The first one is architecture. Architecture is machinery that an AI agent executes on. Then agent function. It is used to map a percept to an action. Then agent program. It is an implementation of agent function. An agent program executes on the physical architecture to produce the function. Then we'll discuss about PEAS representation. PEAS is a type of model on which an AI agent works upon. When we define an AI agent or rational agent, then we can group its properties under PEAS representation model. It is made up of four words: performance measure, environment, actuators, and sensors. Here, performance measure is objective for the success of an agent's behavior. For example, the first one is self driving car. Performance, safety, time, legal drive, and comfort. Then, environment, roads, other vehicles, road signs, and pedestrians. Then, actuators, steering, accelerator, brake, signal, and horn. And finally, sensors, camera, GPS, speedometer, odometer, accelerometer, and sonar. The second one is medical diagnosis. So its performance is measured by healthy patient, minimize cost, and the environment will be patient, hospital, and the working staffs in hospital. Then actuators, test and treatments undergone. Then finally sensors, keyboard, that is entry of symptoms. Then third one is vacuum cleaner. Its performance is measured by cleanness, efficiency, battery life, security, etc. And its environment is patient, hospital, and staff are in home. Then actuators will be wheels, brushes, vacuum, and extractor. And finally, sensors is camera, dirt detection center, cliff sensor, bump sensor, and infrared wall sensor, etc. The final one is part picking robot. Its performance is measured by percentage of parts in correct bins. Then in environment, it has a conveyor belt with parts and bins. Actuators, jointed arms, hand. Then sensors, camera, joint toggle sensor, etc. Type of AI agent. Agent can be grouped into five classes based on their degree of perceived intelligence and capability. All these agents can improve their performance and generate better action over the time. These are given below: simple reflex agent, model based reflex agent, goal based agent, utility based agent, learning agent. The first one we'll see about simple reflex agent. These agents take decisions on the basis of current percepts and ignore the rest of the percept history. These agents only succeed in the fully observable environment. The simple reflex agent does not consider any part of percept's history during the decision and the action process. The simple reflex agent works on condition action rule, which means it maps the current state to action. Such as room cleaner agent, it works only if there is dirt in the room. And problems for the simple reflex agent design approach. They have very limited intelligence. They do not have knowledge of non perceptual parts of the current state, mostly too big to generate and to store, and it is not adaptive to change to this environment. Then, model based reflex agent. The model based agent can work in a particular partially observable environment and track the situation. A model based agent has two important factors. First one is model. It is knowledge about how things happen in the world, so it is called as model based agent. Then internal state. It is a representation of the current state based on person history. Updating the agent state requires information about how the world evolves and how the action affects the world. Then the third agent, it is goal based agent. The knowledge of the current state environment is not always sufficient to decide for an agent to what to do. The agent needs to know its goal, which describes desirable situations. Goal based agent expand the capabilities of the most model based agent by having the goal information. They choose an action so that they can achieve the goal. The agents may have to consider a long sequence of possible actions before deciding whether the goal is achieved or not. Such considerations of different scenarios are called searching and planning, which makes an agent proactive. Then the fourth one is utility based agent. These agents are similar to the goal based agent but provide an extra component of utility measurements which makes them different by providing a measure of success at a given state. Utility based agent act based not only goals but also the best way to achieve the goal. Utility based agent is useful when there are multiple possible alternatives and an agent has to choose in order to perform the best action. The utility function maps each state to a real number to check how efficiently each action achieves the goal. And the fifth one is learning agent. A learning agent in AI is the type of agent which can learn from its past experiences or it has learning capabilities. It starts to act with basic knowledge and then able to act and adapt automatically through learning. A learning agent has mainly four conceptual components which are learning element, critic, performance element and problem generator. It is responsible for making improvements by learning from environment. Learning element takes feedback from critic which describes that how well the agent is doing with respect to a fixed performance standard. The performance element. It is responsible for selecting external action. And the problem generator. This component is responsible for suggesting actions that will lead to new and informative experiences. Hence, learning agents are able to learn, analyze performance, and look for new ways to improve the performance. Then, agent environment in AI. An environment is everything in the world which surrounds the agent, but it is not a part of an agent itself. An environment can be described as a situation in which an agent is present. The environment is where agent lives, operates, and provides the agent with something to sense and act upon it. An environment is mostly said to be non-feministic. The features of environment. As per our author, an environment can have various features from the point of view of an agent that are fully observable versus partially observable, static versus dynamic, discrete versus continuous, deterministic versus stochastic, single agent versus multi agent, episodic versus sequential, known versus unknown, accessible versus inaccessible. Next, we'll see about Turing test in AI. In 1950, Alan Turing introduced a test to check whether a machine can think like a human or not. This test is known as the Turing test. In this test, Turing proposed that the computer can be said to be an intelligent if it can mimic human response under specific conditions. Turing test was introduced by Turing in his 1950 paper that is Computing Machinery and Intelligence, which considered the question can machine think. The Turing test is based on the party game imitation game with some modifications. This game involves three players in which one player is computer, another player is human responder, and the third player is an human interrogator who is isolated from other two players and his job is to find the which player is machine among two of them. Consider player A is a computer, player B is human, and player C is an interrogator. Interrogator is aware that one of them is machine, but he needs to identify this on the basis of questions and their responses. The conversation between all players is via keyboard and screen, so the result would not depend on the machine's ability to convert words as speech. The test result does not depend on each correct answer, but only how closely it responds like a human answer. The computer is permitted to do everything possible to force a wrong identification by the interrogator. The questions and answers can be like the interrogator asks, are you a computer? For that, a player either is computer replies no. Then the interrogator asks to multiply two large numbers in many digits. Then player A, after a long pause, gives the wrong answer. Chatbots to attempt the Turing test. ELISA. ELISA was a natural language processing computer program created by Winsenberg. It was created to demonstrate the ability of communication between machines and humans. It was one of the first chatterbots which has attempted the Turing test. Parry. Parry was a chatterbot created by Kenneth Colby in 1970. Parry was designed to simulate a person with a paranoid schizophrenia, most common chronic mental disorder. Parry was described as Elisa with attitude. Parry was tested using a variation of the Turing test in the early 1970s. Eugene Guzman. Eugene Guzman was a chatbot developed in St. Petersburg in 2001. This bot has competed in the various number of Turing tests. In June 2012, at an event, Guzman won the competition promoted as largest ever Turing test content in which it has convinced 29% of judges that it was a human. Guzman resembled as a 13-year-old virtual bot. Features required for a machine to pass the Turing test are natural language processing, knowledge representation, automated reasoning, machine learning, vision, then motor control. Natural language processing is required to communicate with interrogator in general human language like English. Then knowledge representation is used to store and retrieve information during the test. Then automated reasoning. It is used to use the previously stored information for answering their questions. Machine learning is used to adapt new changes and can detect generalized patterns. Then for vision, for total Turing test, to recognize the interrogator actions and other objects during a test. Then motor control for total Turing test. It is used to act upon objects if requested. The topics we have covered are one of the basics of artificial intelligence. Hope you all understand the lecture, and if you have any doubts, you can clarify. Thank you. Thanks.